Good morning, all. Today we are going to see about IoT communication models. The Internet of Things relies on various communication models to enable devices to collect, process, and exchange data over networks. Understanding these models is crucial for designing efficient and scalable IoT systems. This presentation will cover four primary IoT communication models which are request response, publish subscriber, push pull, and exclusive pair communication. First one is request response model. The request response model follows a client server architecture where the client initiates a request for an information or a service. The server receives the request, processes it, and sends back the required response. This communication is synchronous, meaning that the client must wait for the response before proceeding with the another request. Advantages in this request response model are simple to implement, suitable for application requiring direct response, ensures data consistency. Disadvantages are high latency and inefficient for large-scale IoT networks. Here, the high latency is due to when the client initiates a request, the server has to process it and sends back the required response. For that amount of time, the client has to wait before making any other request. This is the block diagram of request response model where the client initiates a request, service receives it, and processes the request with the help of the resources it had and responses to the client. Here I have taken the example for request response model where a smartphone initiates the request to the IoT smart thermostat to get the current room temperature. Here the protocol used is HTTP, where HTTP is explained in further presentations, and the server replies with OK message and the required information requested by the client. The major use cases of request response model are smartphone assistants. The smartphone assistants like Alexa or Google Assistant use the request response model. When we ask a question, it sends a request to the server where the request is processed at the server side and the information is again given back to the client. The second model is publish subscriber model, where the publish subscriber model is an asynchronous communication. This is the communication model where there is a medium called broker between the server and the client. Whenever the server sends the message to the broker checks for the client that are requested for the topic. Where this is the block diagram, the publisher. Here the server I mentioned is publisher. Publisher sends the message according to the topics. The broker receives it, and broker has the responsibility to take care of forwarding this message to subscribed consumers. Here I have taken the use cases as temperature monitoring system. The major use cases are smart agriculture, where weather monitoring systems publishes the temperature, humidity, and soil moisture data. This will reach the farmers or irrigation controllers that are subscribed to a specific topic. The third one is the push-pull model, where the server puts the data into the queue and the client receives the data from that queue. Here the publisher, this is the block diagram. Here the publisher sends the message into the queue and consumer pulls from this queue. The real-time applications we can consider as charts or reels where the server puts already the messages into some memory location. We are fetching that memory location by one. Here I have taken as IoT data collection from multiple sensors. Since we have multiple sensors, one node cannot acquire the data from all the sensors at the same time. So the sensor data are pushed into some kind of memory where we are often called this as queue, and the receiver pulls the data from that memory location. The use cases are industrial monitoring system. And then fourth is exclusive pair model. In exclusive pair model, where two devices establish a dedicated connection for a direct communication, two devices creates a persistent direct link for execution data chain. This connection is stateful, meaningful, maintains the session until one of the device disconnects or uh, requests a connection, close connection. This is the block diagram of exclusive pair. First, the client request for the set of connection. The server responds with accepting the request and the data transfer between them occurs. Then the connection closing request arises. Here, I have taken as use case as secure wearable devices. The comparison between IoT communication models are request response model are synchronous communication. This takes the where the server and client communicates directly without any kind of buffer or memory intermediate between them. The best use cases are smartphone assistant, industrial IoT. Scalability is low, complexity is low. And the second one is the publish subscriber model, where the type is asynchronous. It means that between the publisher and the subscriber, there is an one intermediate device or logical thing called broker that stores the information from the publisher and give to the subscriber according to the topic subscribed. The scalability is high, complexity is medium. Best use cases are smart agriculture and smart traffic. And third one is the push pull. This is also a asynchronous communication because between the sender and the receiver, there is a buffer called queue where the sender push the data into the queue, client takes the data from the queue. There is no direct communication between the sender and the receiver. Best use cases are industrial monitoring and environmental IoT. Scalability is high, complexity is medium. And the last one is the exclusive pair, where the type is synchronous because the connection between the server and client or sender and the receiver are directly occurs. And the major difference between the request response and exclusive pair is in request response, the server and the client are fixed. But in exclusive pair, the server and client can be interchanged. Sometimes one device can send to the information to second device. In another time, second device can send the information to the first device. This can be according to the use case. So here the server and the clients are interchangeable. The communication style is direct, which means persistent connection. Best use cases are smart healthcare connected vehicles. Scalability is low, but the complexity is high. Thank you.